Okay, so here's the next part. We're going to do a little bit of, again, a review of some stuff hopefully you've seen before, can remember from before. Our trigonometric ratio for right triangles. So again, right triangle, got the little thing in the corner. We have two other angles. So this is my 90-degree angle, always going to be my 90-degree angle. These two other degrees are going to add up to 90 as well, because the whole triangle is 180 degrees as a reminder. So remember, the sum of angles in a triangle is always going to equal 180 degrees. Okay, so now the idea of our trigonometric ratios, it all depends upon what angle we're referencing. So let's say we start from this angle. That angle right there, angle alpha. So there are three sides. Now, I know when we did hypotenuse, we called them legs, but when we have them as a reference, we're going to rename those legs. So this guy is still going to be the hypotenuse. But now what we're going to say is we're going to look for opposite sides and adjacent sides. So in this case, if I look from alpha across from it, this guy right here is going to be known as the opposite side. It's opposite the angle alpha. This one down here is going to be the adjacent side. It's next to the angle alpha. So your trigonometric ratios are sine, cosine, and tangent. And the way to remember what they are is, I think your teachers in the past may have told you about this way. SOHCAHTOA. It's just a way to remember the ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So in this case, what's going to happen is for sine of alpha is going to be this opposite side over the hypotenuse. It's the ratio of this to that. Cosine, AH, so it's adjacent over hypotenuse. And the last one, tangent, opposite over adjacent. So that is from the reference point of the angle alpha. If we do it from the angle beta, things change. Now first, the hypotenuse is going to stay the same. Hypotenuse is always going to be the one across from the right angle. So it's always going to be whatever's across from the right angle. But now, what used to be adjacent for beta is now considered beta's opposite. And what was once opposite for the alpha is now going to be adjacent for beta. So it's a reference. You got to make sure you draw it. So I would always put the little hoop on the angle and then kind of label them as OA and H, OA and H. Because what's going to happen is it's still going to be opposite over hypotenuse. It's still going to be adjacent over hypotenuse. And it's still going to be opposite over adjacent. But what's going to happen is, if you notice, these reference sides are going to change from when we go from one to the other. So what we're going to do now is we're going to do a couple practices. So what I'm going to do is I'm going to do one of them, and I'm going to do the angles you would see. So in this case, sine X. So what I would say again is there is angle X. So now let's label all the pieces of the triangle. Here's my right triangle, my right angle. Sorry, my right angle. Across from that, 39 is my hypotenuse. And then what I'm going to do is I'm going to label 36 is next to the angle that's adjacent, 15 is opposite it. So it's asking me for sine X. Sine X is opposite over hypotenuse, so SOH. And what you're going to do on that one is you're going to do the ratio of the sides. So in this case, sine X is going to equal the opposite side 15 over the hypotenuse 39. You're going to pick up your calculator and to 10 thousandths, that's 4 decimal places, sine X is going to equal 0.3846 in your calculator. If I wanted to figure out cosine of X, what's going to happen is cosine is adjacent over hypotenuse. So in this case, cosine X is going to be the adjacent side 36 over the hypotenuse, so 36 over 39. And again, you're going to pick up your calculator, which I should have handy right here. And we're going to do 36 out of 39, and we're going to find out that cosine of X is going to equal 0.9231. And last but not least, I'll do tangent of X. Again, sine, cosine. No, I'll do tangent of X. And tangent of X is going to be opposite over adjacent. So what that means is the tangent of X is going to be 15 over 36, opposite 15, adjacent 36. So my tangent of X is going to be 15 divided by 36. So this one is going to be 0.4167. So that's what would be if I used X as my reference angle. It would change if I used Z as my reference angle. So the only two reference angles we're going to use are X and Z. Why? We're going to talk about what the measures of those, because it's always going to be taking the sine and cosine and tangent of 90, and we're going to learn what those are. We're going to move as we move forward on Friday. We'll talk about that. So if I wanted to figure out, let's say, for example, the cosine of Z, it's still adjacent over hypotenuse. But what happens now is this side right here is now my opposite side to Z. This side right here is now my adjacent side to Z. So now if I wanted to go ahead and do adjacent over hypotenuse, I'm going to do 15 over 39. 15 out of 39. And what that's going to be is we're going to find out that the cosine of Z is going to end up being with that same answer here, 0.3846. So it depends upon your reference angle. So we're going to practice that in class. There's about, 10 of them that we're going to practice just to make sure we feel comfortable with it. That's all we're going to do. That's all we did today. So hopefully that helps a little bit. Please do the practice. Please make sure you feel comfortable with the calculator.